Hello, this is Per Magnus Lindborg. I'm going to take a couple of minutes to speak to you about the max patcher part of the Pacific Belltower sonification installation. Now, this is an idea that I've been having in my mind for several years, and I really started to work with it for real in 2016 and then into 2017. I done the sonification project called Locust Wrath, but then I wanted to work with a different kind of material and also for a slightly different setting. So I'm going to show you here what happens in the Max Patcher. Now the installation itself is meant to be. It is being played in a gallery setting, in a lobby, and the loudspeakers are stacked up in the middle of the space and projecting the sound outwards to the walls and then reflecting them back. And that's how the immersive soundscape is being created. So it's a 4-channel surround sound, but for the sound projected outwards. You will, of course, hear in this short example, you will just hear stereo sound, but the main focus is really what goes on in the patcher. So I'm going to reduce this image of myself, and you will see the Max Patcher here in the background. Yeah, so there's several things going on in this patcher. Over here we have the clocking device. It says every quarter of the hour, and we have the tick-tock of the local time, where we are on the planet, and you will see why this is important in a moment. And here we have an offset for the local time to have universal time coordinates. Over here we are downloading data, going online and downloading data on a server at the IRIS Institute. So that's a research institute in seismology, so earthquakes and volcanic activity from all over the planet is being uploaded to this site regularly. And the Max Patcher is going to retrieve these data 4 times every hour and then play a short 90-second condensed version, if you want, of everything that's been going on in earthquakes all over the planet, but compress these and spatialize them out, sort of point towards where an actual earthquake was happening just very recently. Here, if I you see here that it's 9:42, and you'll be starting at 9:45 will be the next launch of the strike of this heel of this bell tower. Now I can force it by just clicking a button here, and I will do so in a moment. But before that, I will show you there's also a little map if you want. So here's see a couple of dots, and they illustrate sort of the view of the planet Earth from a certain geographical position, and each dot represents one registered earthquake. Now, I would also say something about the scaling or the parameter mapping here. This is very important, of course. So the data. Sorry about clicking around here a bit. I open this window and show you what the data looks like once it's downloaded into or retrieved from internet into Max. Here we go. This is what the data looks like. So the most recent detected event was, it says -14, so that's 14 hours ago. And then it says the location. The third column here is the latitude. We have the longitude. We have the magnitude on the Richter scale. And the last column is the epicenter depth in kilometers below the surface. You see here that we have hundreds and hundreds of recent earthquakes from all over the planet being retrieved. I think that this is going to start any second. So I will just let it run and then maybe say a few words at the end of that. So here we go for the start of Pacific Belltower about to strike. Okay, testing. Yeah, microphone sound is back. That was one peal of the Pacific Bell Tower, and 500 events were played over just under 1 minute. So it's just a signal, and of course the poetic idea is to alert, if you want, like bells at a church or something like this, that will be alerting danger, some precipitating catastrophe perhaps, or just reminding us that this activity is actually happening all over the planet and that we need to be aware of it. So as we saw, the data is latitude, longitude, that's spatial data, and we have the magnitude, which is the energy. Sorry. And then we have the magnitude and the epicenter depth. So last thing, I'm just going to show you how this is being mapped in the patchers. We have the depth parameter to a pitch of these virtual bells. We have the magnitude going to the harmonicity of the bells, and of course the geographical location is the spatialization in this 4-channel space of the installation. The synthesis itself is a very straightforward FM synthesis. Looks like this, and this is a bit of a classic, and I think that I will be developing this further when I continue working on this installation for the next work. Now, if you want to see how this sort of looks like in practice inside an installation space, then there's some video clips from the Yale NUS tryouts in Singapore. There's also the preview at the Aalto University in Finland, and the first real exhibition, which was in Shanghai for the ICMC 2017 at the Shuhui Art Gallery. So thank you very much for your attention. This has been Per Magnus Lindborg speaking about Pacific Belltower sonification installation.